Thanks. So when we launch a PySpark session, so it is going to create a object for the Spark session object in the name of Spark. So using Spark, you can generally access the PySpark APIs. That's what we started exploring last two sessions. So and we started with the Spark transformation and actions. So we will cover some more transformations today. Okay, and also I will tell you the little bit of how the Spark architecture works. Okay, so so when we launch a PySpark session, I don't know whether it is showing here. Okay, so there will be a Spark web UI for your application. Okay, so either you start a PySpark session, or when you create it as a Spark cluster. Okay, so when you will have a Spark web UI for Spark, sorry, PySpark session. So it will start in the local port number called 4040. So if you say localhost 4040, there will be a Spark web UI. Okay, so it look like this. So it says PySpark shell. We launched as application UI, and you see multiple tabs available. So each tab gives some metrics or information about your application running on Spark. Okay, so here the moment we start creating jobs, you see like start running your jobs. So it will create the jobs here, and I will tell you the. So generally, when we'll have a Spark application, the Spark application will have one or more jobs, and the jobs will have one or more uh, stages. Then the stage will have one or more tasks. So that's how it is organized. So we will see what are the information we can get from these tabs. So storage, and you will see environment. So basically it will tell you about what your Spark cluster about. Since we launched Spark PySpark CLI, so it says PySpark shell, and it is running on local mode, and it has driver process listening on this port. Okay, and you will see uh, other metrics about how many how many executor process running, and what is your driver process, and what is the kind of resource allocated to that process. And also you will see a Spark SQL tab. So if you are using Spark SQL, some of the metrics about your Spark SQL will be coming here. Okay, so we will explore this web UI in detail when we launch some specific jobs. So just to give you okay, so before we go into, we take small code, and we'll small PySpark code, and we'll run it here. And before I go there, I will start tell you about little bit about the Spark architecture. Okay, this we discussed earlier. So we have the Spark Apache Spark is a unified analytics engine for large scale data processing. So it has these ecosystem components. We already saw it. So if you want to just high level, what is difference between Hadoop and Spark? Okay, so Hadoop basically meant for both distributed processing and distributed storage. The mainly it's just distributed storage and processing. First, distributed storage, it has SDFS. Ideally, Spark does not have any storage layer, so makes use of Hadoop storage or any other distributed storage, even local storage. Excuse me. And then for computation, So it has Hadoop has a MapReduce computation engine. Spark has its own computation engine, which is what we are going to discuss, which is very efficient and faster because it's going to do the in-memory processing. Yeah, so that's in the next point to discuss. Hadoop is faster, okay, comparatively for the large data set on the uh, cluster of computers. And Spark claims it is 10 to 100 times faster based on the workloads. Okay, so because of it is in memory, and if the data is cached, those type of workload, it's 100 times faster than the Hadoop system. And resource management, Hadoop has a yarn resource management. For Spark, it has its own standalone resource management component, okay, or module, you can say. Okay, so Hadoop lacks in there are two areas, which is iterative machine learning and interactive data analysis. So iterative machine learning, basically in Hadoop, there was component called Mahout. It's Mahout. Okay, it is based on the MapReduce. So this is the component which was used for machine learning implementation using Hadoop. Which, since it is using Hadoop, so it has to depend on the MapReduce. So in the machine learning, what happens is there are a lot of iteration used to happen. So each iteration, the first iteration output has to be used by the second iteration. So since Hadoop cannot pass the first output to the second job, basically it has to store in HDFS and the next job has to pick. So we have to do a lot of uh, things using MapReduce. So it was difficult doing the iterative machine learning using MapReduce, and interactive data analysis. Yeah, so interactive data analysis using MapReduce you cannot achieve, but it was achieved using Hive or Pig-like components. Okay, but still it is lagging in the terms of performance. So that's where Spark is very helpful to overcome those issues which was faced in the MapReduce in terms of interactive machine learning, iterative machine learning and interactive data analysis. So intermediate data is kept in memory in the Spark. Okay, uh, to reduce the number of read and writes to the disk, which helps to perform the computation faster and efficient. So we know in the MapReduce we seek the disk for, because we'll process sequentially in a MapReduce. Okay, so in the interactive data analysis, we in the interactive data analysis in Spark we have a rich set of functions to do data analysis. Speed up the data analysis by caching the data in memory. Okay, so this is the basically kind of things which will happen in a Spark. Okay. Okay, so whenever you write a program, say example, I will go and show you one program. Okay, I take this example. Okay. Okay, this is my PySpark program. Okay, so I imported the necessary packages. Then I created a Spark session object. Okay, so Spark, if you want to create a Spark session object, So once we import the Spark session from PySpark.sql, so there's a builder method. Using that, you can create a Spark session object. So Spark session dot builder, and you can pass different properties. So one is the application name you can pass, and another is the master property. So master property is very important property. Uh, this helps you to run your Spark job, uh, whether you want to run it on local, which uses the JVM machine, which at the end of the day, your Spark application will be run on JVM, okay, Java Virtual Machine, right? So whether you want to run it on your local Java Virtual Machine, or if you want to run it on the cluster, okay, so it might be a Hadoop cluster, or it might be a just Spark cluster, okay. So if you are using Hadoop cluster, you are going to use Yarn. If you are using a Spark cluster, just Spark cluster, you are going to use the Spark standalone mode. Okay. So which generally okay. So these are the execution modes, values. If you want to show. Okay, so if you want to use the local mode, then you will say hyphen master. Okay, so specifying hyphen master. So we will okay. So ignore about this Spark submit and hyphen master. When we submit our Spark application through cluster, we have to use Spark submit. Since I am running in my means in my PyCharm IDE, I'm actually creating this Spark session object and providing these details. So master values can be local, which can specify even JVM multi-threaded way you can run your application. And then there is other, like this is a local mode. If you want to run it on Spark cluster, and you can use the cluster, your Spark cluster master web UI. Okay. So again, Spark is also master slave architecture, right? So you will have a master process. Um, and we have a slave process. Okay, so here so you need to submit your Spark cluster manager uh, to actually negotiate your resources. So in terms of Spark standalone manager, you have to use this URI. So basically master will be configured one of the node in your Spark cluster. So you have to specify Spark :/ that port IP address port number. So generally default port number for master in a standalone cluster is 7077. Or you can use another type called yarn, and then when you want to use the Spark Hadoop cluster for running your Spark job, and then the other one is Mesos. This is also one of the cluster manager, and recently the Kubernetes also supported in running your Spark job on the Kubernetes cluster. Okay, so these are the different ways you can submit different cluster managers, you can use it in a Spark application when you're running a Spark application. Yeah, this is given details. Just make note of it. I want to go through these two link whenever you get a time, so it will give you more information about you are running your Spark application. Okay, so that's I just want to tell you about the master, and then you can actually support your Hive environment using Spark. So just we can enable using a dot enable Hive support method, and then finally dot get and create will give you the Spark session object. Okay. So once you create a Spark session object, so we can again access your Spark session Spark APIs, PySpark APIs. So it's very similar to here when we launch a PySpark session, this object is already created, okay, by the framework. In this case, when we run it on a standalone program, when we develop a code, we have to do this, okay. So once you have a Spark session object, so we can access, so you can use the you can access the Spark context uh, dot parallelize method to convert your Python object, Python list, which has number 1 to 10. I'm converting into numbers RDD. Okay, just a minute. I'm sorry, I have to take one call. Okay. Okay. So now, so we created a number list and we just converted the number list into RDD, which we already discussed in the earlier classes. So also you can also find the number of partitions for your RDD. So since we created as uh, um, RDD with the 3 partitions, it's going to give you 3. Okay. Now there is a there is a there is a transformation called sample. Okay, so this sample transformation, it is going to give you the what's so basically we given a RDD which is number 1 to 10. Okay, so takes 3 argument, the sample transformation. One is with the replacement, and the second argument is a fraction, and third is a seed. Okay, so we'll discuss what these arguments is about. With replacement, can elements
be sampled multiple times, replaced when sampled it out. Okay. So so we'll come to this later. So fraction basically expected size of the sample as a fraction of the RDD size. So say if I have this, so a sample will give you how many times basically your the elements has to be sampled. So it's good kind of say I have one. Okay, so each element how many times it has to repeat kind of it. So that's basically a fraction, nothing but, and it is chosen based on the okay, so the fraction must be, the fraction value must be 0 to 1, no, not 0 to 1, basically it will be 0 1 or 2 like that. Okay, so okay, then the seed. Okay, seed is basically will give you, like, say example I generate this is the our input. Okay, so I generate a sample, say it generated some list, sorry, RDD with a set of numbers. If I run one more time, I want to generate the same, because it's going to generate the kind of some random uh, gen a random set of numbers based on these numbers. Okay, so whether if you run again and you want to get the same output which we do in the last run, so basically you can use a seed. So seed will generate same number of random numbers whenever you run again and again. Okay, so and I'll just once the sample is created out of this RDD, the input numbers RDD, I'm just collecting it and printing it here. So when we run this, okay, so first I will run and show you. I'm running this. So this is the sample output which is come out of that whatever the input you passed. Close this. Okay, so this is the input and this is a sampled output. Okay, so the, and also it is somewhere it is mentioned it is, okay, I will pass fraction as 1. What is happening? It is generated 19 elements. Basically, if I say 4, it generated 55. So generally, what they say is basically this fraction, based on the fraction, uh, uh, the sampled size for your input date. So basically, it has to generate some 40 elements. So we pass 10 elements here, but it has to uh,
get some close to 40 or close to 40 elements range, but somehow it is giving this value. But internally, what happens? Basically, I'm not sure. Okay, so basically, mostly it is used for kind of some if you have input, if you want to get do sample your data and generate some random set based on the input data, we can use this transformation. Okay, so now basically what one more thing I want to highlight here, I will just if you come down, I'm stopping the Spark session object. Okay, so before stopping the Spark session object, I will just stop here. Okay, just say I think input, right? Uh, uh, Sequence number. I'll try to take just the input function I'll call. Okay, this is to stop my like pass the execution till here, so that I can actually show you the information from the Spark Web here. And before this, so this is going to generate the sampled the sample underscore number RDD list will have the sample output, right? So before that, I want to apply the map transformation. So we have a RDD numbers RDD, and we applied a sample transformation, and then we collected RDD. Okay, so I will run this program. Okay, so it is waiting here, waiting for the input. Okay, and I will show you this localhost again 40, because since we are running on local mode. So you see here, okay, so there is a job created whenever we run our Spark application. There is one job created. How this so the application, the Spark application might have one or more jobs. Okay, so how the uh, job is triggered based on the action operation you perform. Say example, look at this program. So what I am doing it in this program, I'm basically creating a Python object, and out of Python object, I'm creating a RDD. Okay, this is a transformation operation, and then you see I am actually doing a one action operation. That is means I want to see the output of this the sampled RDD. Okay, for that I'm using a collect operation. So whenever you apply a action operation, which is like collect, take, or saving the output to the any file system, the during the action operation there will be a job triggered. Okay, for anyway the application, when you run this Spark application will be created, and Spark application will have jobs based on the number of action operation you perform. Okay, and if you go to the particular, so see we see here we have only one stage. Okay, so and the application duration was 3 seconds. If you just click on this description, it is going to show you the stage jobs. This is basically jobs tab, right? So if you click on this description, it is going to show you the stages. Okay, so what we just did is, so this is a parallelized RDD. Okay, so if you look at this, this number RDD is nothing but just a parallelized object of your Python object. Basically, it's a a parallel collection RDD. That's what this is the input, and from that actually we actually did the collect. Okay, so that is the information it is doing showing here. So whatever operation you perform here, that here showing as in terms of some visual representations called a DAG. DAG is nothing but a direct acyclic graph. Okay, so basically it will show you how you perform your operations in a Spark. Okay, now okay, so that is some of the information I want to show in this. So this will be still you can actually uh, get into more detail about uh, each what is the time it took to perform particular stage, and this. So basically you can get a time execution time based on your job, and also in a another sub level called stages and task as well. Okay. Okay, so okay, so we have 1 minute left. We'll stop and rejoin again, and we'll discuss some more details about the Spark architecture.